Alright, welcome to this video where our goal today is to solve equations using division. Alright, so we're talking division now. We've done addition, we've done subtraction. Now division is a little bit different, but I feel like it'll be something that you'll be somewhat comfortable with. Alright, solving equations using division. So I just want to first recap a couple things that we've talked about recently about solving equations. Okay, so this is really important stuff, things that'll help you. And the first thing that I want to talk about is actually three terms here. The first one is inverse operations. Inverse operations, are operations that undo each other. For instance, um, you could say addition and subtraction are inverse operations. Flipping around, addition undoes subtraction and vice versa. You can also say that multiplication and division are inverse operations. So those are operations that we're going to use to solve equations. When you have addition, you can undo that addition by subtracting that number. Second word is a solution. So we talked about inverse operations. A solution here is simply the value for the variable that makes the equation true. So if you have x plus 12 equals 15, you can solve it, and you know that x is equal to 3, and that is your solution. So your solution is that x is equal to 3. All right, that's the value for the variable that makes this equation true. Now lastly, the word isolate. When you think of isolate, again, you might think of leaving it by itself, trying to make it so that you're isolating something, you're leaving it all by itself. Again, you might think of sports, and they use the term iso or isolate, and that is to get the person all by themselves to go, a lot of times one-on-one against whoever they're working with in basketball or football. You think of people who are isolated in the middle of the desert. They're all by themselves in the middle of the desert. They don't have anyone around them. So that's isolating or isolation. In algebra, isolating is getting the variable all by itself on one side of the equation so that you can ultimately solve for it. So if you get the variable all by itself on one side, you end up solving for it, and you get x equals whatever, or whatever the variable is. Now, the golden rule, and this is something that I think is really important. I keep saying it, but the golden rule of algebra, what you do to one side, you must do to the other. And obviously, we're talking about equations here. So if you want to think of, and if you want to think of here, I'll bring this over just to help you out. If you want to think of the balance, all right? If you're looking at a balance, a scale like this, or a teeter-totter, or something similar, if you add something to one side, in order to keep it balanced, you have to add that same thing to the other side. Okay, if you add 5 to one side, you have to add 5 to the other side. If you subtract something from the one side, you have to subtract it from the other. All right, so let's try a couple here that are refreshers from yesterday. So first of all, you got to remember to isolate the variable. All right, so if we're trying to solve for x, isolate that variable. So we're trying to isolate x here. In order to isolate x, we have to get rid of everything else that's on the side with the x. And that, in this case, would be the 15. But how do you get rid of a plus 15? So it's 15 plus x. They're added together. And if you look up here, the inverse operations of addition is subtraction. So let's do some subtraction. To get rid of 15, you subtract 15. All right, but looking at that golden rule, and I'll divide it so you know that that's the divider. What you do to one side, you have to do to the other. Let's subtract 15 over here. All right, the neat thing about subtracting 15 on the left side is it cancels that out. It makes 0. And then you still have the x. And it says that x is equal to whatever 12 minus 15 is, which is a negative 3, because 15 is a negative, and it's a bigger number there, so it's going to be a negative 3. And what do you know? We isolated x. We found the solution of x equals 3. All right, let's try one more. Looking over to the right, we have 1.25 equals m plus 0.75. Now, if you remember, we want to isolate that variable. All right, so that's m. We're going to keep that by itself on that side. And what we can do is get rid of that 0.75 by subtracting. So this is adding 0.75. Let's do the inverse operation and subtract it. But remember that golden rule. What you do to one side, you must do to the other side to keep it balanced. So let's subtract 0.75. All right, again, the nice thing is this cancels out. That's 0. So it doesn't matter, it's nothing. You have m equals, let's see, you do 0, far from there. Got 12 minus 7 is 5, 0.5. So m equals 0.50, or m equals 0.5. Again, that variable is isolated. We have solved for m. The first one we used, or actually for both of these, we used the subtraction property of equality. So what we're going to do today is we're going to use this new property. It's called the division property of equality. Now, the division property of equality is very similar to both the addition and subtraction one, only we're using division for this one. Makes sense. The division property of equality says that if A equals B, so remember A equals B, that's an equation, then A divided by C equals B divided by C. If you notice, the only thing that changed is you divided each of the sides by C. Everything else is the same. It's A equals B on both sides. It's just they're both divided by C. So in other words, you can, so we're going to circle this part, you can divide each side of an equation by the same thing while still keeping it balanced. Okay, it's illegal to do that. The addition property said that you can add the same thing to both sides. The subtraction property says you can subtract something from both sides. And keeping that consistent, we can look at a scale, and instead of adding 5 to both sides, well, let's just divide. Let's say that's division instead. So we'll divide both sides by, sorry. We will divide both sides by, all right, if I can figure this out here. All right, so we will divide both sides by 5. All right, what you do to one side, you have to do to the other. This property says we can divide both sides by 5, and it will be legal. All right, so let's use that property. I have 2 examples here. So remember that property there. We'll stick with the first one first. It says negative 8n, and again, remember, that is multiplication. That is multiplication right there. All right, that is multiplication. So negative 8 times n equals negative 64. Now, if you remember anything about inverse operations, we said that the inverse of addition or multiplication is division. So if we want to undo this multiplication, we have to do division. All right, so let's do some division here. If you divide both sides, again, same thing. We're going to get rid of that negative 8 by dividing by negative 8. Okay, and this is our divider. But what you do to one side, you must do to the other. So we'll divide this side by negative 8. All right, and when you divide negative 8n by negative 8, the 2 negative 8's, which is really nice, they will cancel out because that ends up making 1n or just n. Okay, so 1n is the same thing as n. So n is equal to negative 64 divided by 8 is a positive 8, because 64 divided by 8 is 8, and a negative divided by a negative is always a positive. So now we have n by itself, isolated, solution is n equals 8. Now the nice thing is we can check that. So if you remember back to yesterday, you can check it by plugging it back in. So if we take this and we go, plug this back into here, that would be, we'll use that in green, we'll use that in purple over here. Negative 8 times 8 equals 64. Negative 8 times 8 is negative 64. And negative 64 is equal to negative 64. So we get a big whopping smiley face. We did it right. N equals 8 in this case. We just used that multiplication, we used that division property of equality. We divide both sides by the same thing to isolate the variable. Okay, so let's try another one. 145 equals 5b. Okay, so the variable we're trying to solve for here is b. And if you want to circle it, if you want to underline it, whatever. But to get rid of everything else on the side of the b, you have to recognize that we have some multiplication here. That's 5 times b. Okay? And to undo multiplication, well, you divide. So let's divide this by 5. And then remember, you have to divide everything on the other side by 5. Alright? So over here, 145 divided by 5, I believe you get 9. We can check that on a calculator. 145 divided by, sorry, it won't be 9. I lied. It won't be 9. But divided by 5 equals 29. Sorry. 145 divided by 5 is 29. 29 on this side is equal to whatever this is. So 5b divided by 5, I guess 5 over 5, those cancel out again. So you end up getting just b, because that makes, those cancel out, or it makes 1b. Okay, so 29 equals b, or you could say b equals 29. And since b is by itself on one side, it's isolated, and it is solved for. We are done. Big smiley face. But before we do a smiley face, let's, in red, plug that back in for b. Remember, plug it in, plug it in. So, 145 equals 5 times 29. 145 equals, we did 5 times 29 equals 145. And those are equal, so there we get a smiley face. The division property of equality worked. Okay? So, let's just try, I want you to try these two. So if you want, you can pause it. I would like to see your work for these. Alright, here's what we're going to do. Same thing. To get rid of this 5, because we want to isolate the x, we want to isolate this x, divide both sides by 5. So get rid of that 5, you divide by 5. Do the same thing over here by that division property of equality. You end up with just x equals, let's see, what is 17 divided by 5? I believe it's going to be 3.5. We'll check it for sure. 17.5 divided by 5 equals 3.5. I was correct. X is by itself. We are good to go. X equals 3.5. Again, if you want to check that, plug it back in there for the x value. Last one. This one's kind of tricky. 7r equals 7 over 2. Now again, we want to solve for this r. We want to get it by itself. We want to evaluate it. So we'll divide both sides by r, r7. But if you divide this side by 7, I don't remember how to do that. So you have r left over here. But if you remember, when you divide by a number, you divide by a fraction, you multiply by its reciprocal. So we'll take this over here. And you have 7 halves times its reciprocal, which is the flipped version of 7 over 1, which would be 1 over 7. And then you can get your answer. You end up with 7 over 14. And that we know, if you reduce it, is 1 half. Okay. Let's check that one. With our handy dandy green here, we plug it in for R. You have 7 times 1 half equals 7 halves. If you multiply this, you multiply 7 times the top, which is 7, divided by 2, which would be 7 over 2 is equal to 7 over 2, and we're good to go. Smiley face. So our answer for this one is R equals 1 half. That is our solution to this equation. All right, so one question for you, and I want you to think about this. If a one-step equation includes addition, so you can make up an example, let's just say like x plus 5 equals 10. Should you expect to solve it by using addition? Should you expect to solve it by using addition? Why or why not? So think about that for a second. Write down your answer. Now, we talked about when you have addition, you don't solve it by using addition. You solve it by using its inverse operation. And if you think of the inverse operation of addition, that is subtraction. So the answer would be no. You would use subtraction. Because it is the inverse operation. Right? And of course, with x plus 5 minus or equals 10, you grab that and you can you just subtract both sides. So you subtract both sides by 5. And this will cancel out. You get x equals 10 minus 5, which is 5. Subtraction. All right, so that's a good question to think about. Now, lastly, I want you to answer this question and bring it to class tomorrow. Write a problem that you can model with a one-step equation. Could use addition, could use subtraction, could use division, whatever you want to do. Write the equation. All right, actually think of a real example. Write the equation and solve it. All right, so think of a real example. It might be easier to think of one that has addition or subtraction, but then I want you to write the equation and solve it for us and bring that to class tomorrow. All right, so going back to our goal of solving equations using division, I hope by now you are able to use that property, division property of equality, to divide both sides and solve for our variable.